Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management.
GitLab is a single application for the entire software development lifecycle. From project planning and source code management to CI/CD, monitoring, and security, GitLab helps enterprises deliver software to market at new speeds.
Hi, it's B. Cameron Gain, correspondent with the New Stack. And we're here today to talk about scaling and some of the challenges associated with scaling, especially in today's highly distributed microservices environments. I'm here today with Christopher Lefelhocz, Vice President of Development for GitLab, and Ben Sigelman, co-founder and CEO of Lightstep. Thank you both very much for joining us today. The developer experience today is, one that offers software engineers a lot of freedom, to create applications at scale. And as I mentioned before, as everybody knows, these environments are highly complex and highly distributed. And at the same time, there are a number of challenges, et cetera, which I'm looking forward to discussing, and including security and just the developer experience today in this context. So I was wondering if you could just start out, just by describing, what is the developer context today and experience especially, and, what has changed and what are some of the main constraints?
So I think from our perspective, the thing that we think about as being heavy pressure is the need for reliability and the need to be constantly available. At the same time, we're seeing a lot of pressure also to be innovative and move quickly during that experience. We've found that balancing those two efforts is super important to a true good DevOps experience. And what we've found is that consistency is super important in that situation. So, GitLab has produced 100 releases over the last 100 months. Every month we release on the 22nd. And that drive for constantly updating the product, as well as making sure that it's reliable and useful during that period of time, is what we found to be a critical aspect of that experience.
One thing though, Christopher, when you talk about consistency and reliability, what are you talking about? Could you give me an example, please, in the context of your developer team and what could go wrong and what you've done to help fix that?
Yeah, so probably a good example is in our product, we are now on our .com site basically deploying daily. We have upwards of 200 merge requests a day, which is changes to the code base that are going on. And there's a heavy amount of automation and testing and validation. But in any given moment, if you're deploying even just once a day and you're having that high of a rate, you're going to see this constant influx of new capabilities and technology. But at the same time, you have a risk associated with that where you're basically balancing that. And particularly in a service-based mindset, there's change constantly going through there. So how you are able to quickly analyze and debug a situation when you have problems actually reach production, and then also how to prevent those problems from ever actually reaching production. That's really what I think of as kind of the key aspects to today's development.
Today, many are speaking about, we are able to do this X number of updates or application changes per day. And they're not talking about, or often though, what happens is, there are a number of testing and bugs, and we don't hear about that as much for whatever reason.
Yeah, and I mean, if we go back to the question that you started with around the developer experience in general, I honestly think it's pretty rough at the moment for a lot of developers who are, at least people who are working in large distributed systems. If I step back and think about how we got here, which I spend a lot of time doing when I'm, dealing with COVID insomnia and the rest of it, it seems to me like we started with big applications that were monolithic, that were deployed, in stages, and we'd have a 2-week release cycle with many release candidates and so on. And it's old news that we've moved to teams to own individual services that can deploy much more quickly. And so the point of all this, of course, was to create independence for the teams and to move to the sort of release cadence that we were just that Chris was just talking about with daily releases to websites, et cetera, et cetera. Okay, great. Now the issue in my mind is it really becomes much more clear when you think about how these services are actually arranged. It's not like you have one service at the top that's your web app, and then this fan out of 100 services underneath it. What actually happens is that they're stacked in many levels. At Lightstep, our customers have all adopted microservices to some extent. So we can actually look at the aggregated anonymous data across all of them. And with literally no exceptions, the way these services are arranged is in many layers. And even when you have like 20 services, you already have 6 or 7 layers of depth in these services. And when you get to hundreds or thousands of services, which our larger customers have, you often see 20 or 30 layers of depth between the top of the stack and the bottom of the stack. I think that's a really important concept. And these deep systems, each layer was designed intentionally to create abstraction and opacity between the caller and the callee. So you create an API, you put a service behind it, and it was actually a design goal at some level to mask the behavior of that service. But the actual fact is that each of those layers can break. And when it does break, everything above it suffers. And this is why, even though individual releases have a pretty high success rate, if you're doing 100 releases a day, or some of our customers are doing 10,000 releases a month or something like that in the aggregate across all of their services, it doesn't take many failures to create systemic issues. Because and this is getting back to why I think being a developer is so stressful, is that the definition of stress is having responsibility without having control. And developers today have a huge amount of responsibility. It's not just their service, it's everything underneath them, which is oftentimes a huge fraction of the overall system, especially if you're at the top of the stack. So you're responsible for all that stuff. If it breaks, you're going to get paged. But you can only control your little piece. The whole point of microservices and DevOps was to have independent control of each piece. So you don't control these things you depend on, but you are responsible for them. And that's why I think extremely good hygiene across CI/CD. It's not just sort of a best practice, but it's the only way to make developers, help developers maintain sanity in this sort of environment where your responsibility is way larger than the one service that you actually have control over. I don't know if that makes sense. I'm desperate for a visual, and I feel myself making it with my hands, but I think that's a really important point, that these services aren't just out there in the ether, like they depend on each other, and the structure of those dependencies really requires a rethinking of the way that we productionize and observe these systems and secure them.
And of course, the fact that these environments are increasingly multi-cloud and a combination often of on-premises, et cetera, those obviously compound these issues. And I guess the question is, though, in the real practices, in a day-to-day, of course, it's the developer's responsibility, but is it that who actually ends up doing the fixes, and how does that usually work out?
We joke around, people talk about MTTR, mean time to resolution, or mean time to remediation, or whatever the R stands for. There are lots of different options, but really a lot of people, what they actually are optimizing for is MTTI, which is mean time to innocence. So this idea that you get paged, it's usually not your fault, actually, and what you're looking for is just clear evidence that there's nothing you can do to solve this problem, and then you can go back to bed. I think that's an anti-pattern and certainly not something to optimize for exactly, but that behavior is very common, where you have a lot of people are awoken because of issues that affect many other parties. To answer your question of who actually fixes it, that's a good question. I think, unfortunately, principal engineers and people who really know where the bodies are buried are often involved in actually remediating serious issues that are more than just rolling back a deployment. Thankfully, most issues are just a bad deploy that got through CI/CD. We should try to prevent that from happening, and you roll it back, or you roll back a config change or a feature flag. That will resolve most incidents. But when it really gets hairy and there's some kind of interference effect or a downstream cloud dependency that's broken or something like that, unfortunately, like really unfortunately, I think that we're still in the world where you need the brilliant people who've been at the company for 5+ years to help diagnose and remediate these things, which is not a situation we want to be in, but I think that's where we're at.
There's a key aspect there that you mentioned in there, Ben, that I find particularly important when particularly talking about developers in the DevOps experience, which is, there's a big difference between solving a problem and mitigating a problem. And I'll describe both. Solving a problem means that you solve it in totality and you actually go fix whatever the code changes or other things. Mitigating a problem says that whatever state you're in is a bad state and you just need to get out of that state to make it better. So to do that, rolling back is an option, as an example. Other options are to decrease, calls to a certain service for a period of time while the situation is managed. So mitigation is, a key aspect that we particularly see in our more senior engineers and principal engineers, particularly in a DevOps environment. And that's actually a real aspect that, is a difference than, say, 5 or 10 years ago, in my opinion.
And keeping in line with today's context, in this COVID pandemic era, how are things changing and what are some of the additional pressures on the developer teams that you're seeing?
So it's been a little different for GitLab. GitLab's an all remote company, so we haven't seen as much of an impact from COVID as maybe somebody who worked in the office. We had built the infrastructure to basically have reliable communication paths and channels, and also set up our basic process and procedures to be 24/7 across the board. One place we have seen it though is people's personal lives being affected, where obviously having the kids at home all the time has affected things. I think the key aspect that you have to make sure of is much like Ben was talking about, the mean time to innocence. You have to kind of set the expectations clearly for what's going to happen in a certain situation, almost like a pre-mortem on the post-mortem of a given incident. So that's what I've seen is a number of companies are adapting in that way to say, okay, we're not expecting people to be in the office, but we are expecting people to be available, particularly in an operational situation.
Yeah, I would echo most of that. And Lightstep was, we had a healthy mix of remote and non-remote work, and certainly in the early days of COVID, there was an adjustment period. I do think in some ways it's actually been very helpful for everyone to develop more empathy for what it means to be fully remote and how to design processes to optimize for that and so on. But looking at the broader ecosystem of companies out there, I have more exposure to our current customers, of course, than others, so I might bias towards that. But those who are in affected verticals, we have customers that are in the travel industry and stuff like that. They've obviously been deeply affected, and I think it's been very anxiety-inducing for a lot of those folks. But we also have, in my mind, there's a joke, it was almost a trope that within Silicon Valley and the tech world that, people would get up there and talk about software changing the world. That Silicon Valley show on HBO, there was that in one of the early seasons, there was a whole meme about everyone getting up on stage and talking about how their, compression algorithm was going to change the world, make it a better place. And it felt a little bit laughable. But the honest truth is that the economy right now is hurting, and I think a lot of the world is really suffering as a result of COVID. But in as much as we're propping things up, that's kind of on the back of the software industry and the internet, making it possible for people to continue to be somewhat productive in some industries. So I think this has been an important time for our industry in general to actually deliver a little bit of the promise where it's, I don't know how we could possibly function from a business standpoint. I don't mean Lightstep here. I just mean the overall, most industries that aren't in real life dependent, like, in-store retail and things like that. I don't know how it would function without software and internet. So I think in some ways it's been a bit empowering in a good way for developers to feel like the missions that they're pursuing with their companies actually have real meaning and importance right now to the world. And it's being tested. And I think for the most part has been a success for the companies that are delivering, communication and collaboration tools and things like that. And we've seen a lot of those companies kind of rise to the challenge, I think, in this moment for the world, which I actually think has been very encouraging. I would throw that in there too, something that we've observed with our customers in those areas.
Yeah, it seems to be something that is not talked about a lot, but I think there are definitely tangible things that that the software industry has delivered and have done a good job of doing, which aren't highlighted that much. So it's refreshing to hear that.
Yeah, I mean, this is sort of a weird thing. It's not that weird, but an odd thing to say. But to me, the most exciting thing was actually a blog post I read that someone at Fastly put out. And it was actually talking about how the internet has degraded successfully during COVID, which when the internet was created in the 60s, the whole point, of course, was that it could withstand, a full-scale nuclear attack because it was decentralized and adaptive and so on. And what happened during the early days of COVID, I mean, internet traffic went up by 50% in a week, which is crazy, like that was not something anyone anticipated. And it did degrade, but that's the whole point. It bended instead of broke. And that to me was, as an engineer, really exciting. And yeah, sure, my Netflix wasn't HD for a couple of days, but that's a fine price to pay for the important stuff continuing to function. So it was actually really interesting to see the technology tested, and it worked so well that I don't think it really became a news story. I don't know if that blog post ever went viral or something. I just thought it was very interesting. They had a lot of data to support the fact that the internet was doing its job in this strenuous time. So it's been a very interesting couple of months, I think, for the technology industry in that regard too.
Christopher, do you agree? And I assume you do. And I would be curious to see, as far as the repository or the, uploading code experience goes, how that might have changed, if at all. Maybe not.
Yeah, I definitely agree. One thing that we've seen is that not only was it that people were at home and then the internet was more heavily used, but people weren't taking vacations as well. So, and we've seen that across a lot of companies where people were actually seeing that they were busier than ever, surprisingly enough, even though the economy for a lot of companies was slowing down, the activity that people were involved in was definitely going up. And definitely having a service that like Ben talks about that bends but doesn't break is super critical in those situations where we've seen customer uptake to the point that we say to ourselves, okay, how do we make sure that we can service people in a reasonable fashion while at the same time scaling to the next level associated with that.
So the developer's experience, indeed has certainly evolved, and it's changed, and then again it hasn't really changed fundamentally. It's working because in this climate, in this context of the COVID pandemic, which is a positive thing, as we just discussed. So at the same time, the developer's experience of just uploading code to a Git repository and then waiting for the tickets to come out, the job tickets to come out to fix bugs. I think we've at the same time, we've already, or prior to the pandemic, we already started to move well beyond that stage. I'm just wondering if you could describe, for the developer teams and those listening, wondering, what their peers are doing. Could you please describe, how that's working? And again, how we've moved so much beyond those days of hopefully not just putting code on a Git repository and hoping for the best.
Yeah, I think there's a lot of complexity that we could go into, and a lot of detail we could dive into around just how much the developer experience has changed, say, in the last 5-10 years. It used to be that you write your code and you'd upload it to a single server, and you'd expect that to be used for some period of time, maybe somewhere upwards of 3 years, where you didn't do much modification to it. And really where we've gone, particularly with microservices, is that your code not only can be developed and deployed to just your service, but also to several services associated with that, which is really invigorating to to an engineer, and it's exciting. But at the same time, the other thing you have to think about is, okay, how do we make sure that as we're making changes that, it's going to work effectively across all those different services in some cases. And what you've seen is you've seen really a preponderance of additional thought process associated with the whole operations experience kind of blowing out. Things around, continuous integration to continuous deployment, understanding those aspects, as well as tracing and capabilities to monitor and logging. And the developer has to be aware of all those different facets, but we don't want them to have to be required to understand in detail all the different facets. We want them to get the most important information associated with a given situation and be able to effectively move on it from there.
Yeah, I'd echo all of that. And we were talking about change earlier and the number of changes that people push out to production. I think that change is really the right way to frame the discussion, both in terms of intentional change and unintentional change, unplanned changes. A lot of the developer experience these days, I think, extends far beyond the commit itself and into the not just the maintenance, but the comprehension of what's happening in production. One of the most significant kind of conceptual mistakes that I see people making, especially people who don't actually work in industry or are new to their role, is to assume that bugs are a matter of things being right or wrong. I would say, I don't have the stats to back this up to a specific number, but certainly the lion's share of significant issues that I see in production, both at Lightstep and in customer environments and just in my career, are not things that were right or wrong, but things that weren't tuned correctly for the workload that was running in production or for some interaction between services, especially when you start talking about SLOs and performance goals and things like that. It's not like it's not a Boolean kind of black and white distinction between things going well and not going well. It's actually quite subtle and chaotic at times. And what I think developers have to do is they have to develop tooling and processes to understand both planned changes and unplanned changes, and to diagnose those things in a principled way that hopefully doesn't require like a huge amount of training or experience in the organization. Christopher talked about tracing, which is near and dear to my heart. At Lightstep, we really don't think of ourselves as strictly being a tracing product. We started with tracing because, in my mind, in these large systems, the only way to understand the relationship between the various services, it has to start with tracing, because that's the only data. It's the only data set we have, literally the only telemetry we have that actually ties things together across the stack and helps explain the changes. But it's really just the scaffolding for observability, which in turn can be used to understand unplanned changes in production. But with observability that's based on tracing, we can take changes even after the fact. To pair the earlier point about remediating things, you can remediate an issue and then go back in time and figure out, well, what actually happened there, and diagnose it so that when you roll forward again, it will actually work. But it's not a matter of, again, the code having a strict bug. It's usually something where the code could have been right or could have been wrong, but it turned out it wasn't tuned correctly. And only with really high quality retroactive analysis from an observability system can we close the loop and roll forward successfully and with confidence. So in my mind, the real circuit here is having observability that understands the entire stack, which basically means it has to be based on tracing at some level, and then being able to go back in time, understand issues after they're remediated, but before they've been actually truly fixed, and use that data to confidently fix them. That can allow developers to get back into the higher velocity cycle where you're just developing new functionality instead of kind of guessing and checking, rolling forward, rolling backward, rolling forward, rolling backward, and trying to get the tuning parameters right by guessing. Because I think most bugs actually have more to do with that sort of thing than just like a straight up mistake, if that makes sense.
Okay, so at the same time, though, how do we characterize the fact that developers are having to assume more operations related tasks? I mean, tracing, of course, is key and crucial, and it can make engineers and programmers that much better. But as we move into this new sphere of distributed systems, microservices, et cetera, we're asking the developers to learn different tasks, and many are operations related. Or maybe that's just the new way developers need to work in the future. I'm just wondering if we can maybe delineate how that will play out in the next few years as far as the developer's role in these processes go.
Yeah, I have sort of a strong opinion about that, so I'll go. There's a huge difference between putting parametric search on top of raw telemetry data, whether it be traces or time series statistics and metrics or ordinary logging. There's a huge difference between allowing people to search over that data and actually providing answers and insights. In terms of profiling tools, the most basic thing that most of us have if you're using a Mac or something is the activity monitor thing, which you can use to figure out why your fan is going so hot or whatever. And that's based on tracing within the kernel of your computer, but it's not like, ordinary users are even aware of that. And I'm using that as a little bit of an extreme example, but in my mind, it's not that we want people to be looking at traces. That is something that should always be an option. And I think the tracing data itself is relevant to many investigations and probably worth knowing about for experts who are doing expert investigation. But I think a lot of this technology is relegated to experts right now because most people are still doing is looking at the raw data, which in the case of traces is really, really complex. So even you can find a lot of things that seem really weird in a trace, and they're actually totally normal. These systems do a lot of weird things in the steady state, and there's so many false positives and red herrings, it's not that useful. We kind of joke around at Lightstep that as the product has matured, our users spend a lot less time looking at traces, and we spend more time showing them some kind of insight that was gleaned from thousands of traces in the aggregate and is much more comprehensible. So I want to delineate that there's a huge distinction between saying we're going to be using more telemetry, whether it's traces or metrics or what have you, and we're going to have end users actually digging through that manually. I think manually digging through that, the signal to noise is pretty questionable for most use cases. What we need to be doing is thinking about the jobs to be done. In my mind, the main job is to understand what caused the change. Whether the change was planned or unplanned. You want to understand what caused that change. That's going to necessarily involve a massive amount of data that even if you were a genius, it's just going to take too long to literally look through all of it. You need a machine to understand your goal and to optimize for that goal. And that's what observability should be doing. The goal is not to train all of our engineers and developers to become experts and understand that telemetry. The goal is to extract the insights from the telemetry and put those insights in front of people in the context of their investigation. And that's a very important distinction between the data and the user experience.
I like the way you framed that, Ben. The way I think about it, probably because of years of working in operational environments, is it used to be that we talked in terms of number of servers that a particular admin would potentially manage, and the numbers would be in the double digits, let's say in the tens, sometimes in the hundreds. And really what we found is that if you want an organization both to scale to meet business needs as well as other needs, you need to have a higher level of thinking about it. Consequently, you don't talk in terms of number of servers per engineer anymore. You talk in terms of how many services are they running, because servers are secondary to that objective. And kind of we're seeing the same thing, I think, in tracing and other areas where to meet that scale, we have to basically be able to quantify and also be able to analyze the things, not just in the particular, but in the large scale nature of it. And we're seeing the same thing in the developer experience where, with 4,000 merge requests a month, we don't look at every merge request, but we do look at kind of trends and characteristics of that through data analysis and other techniques. And that's allowed us to scale just on the developer side.
But for, say, give the example of a 10 to 15 person DevOps team, how would that work out, or how would that play out? And who would you have the resident, or should you have the resident tracing expert, for example, or would that just be the operations person's role? How does that play out usually?
The way I've seen it play out is a lot of times operations roles, if they're truly separated, they'll understand the details of a specific implementation, but largely most of the other team members understand both conceptually as well as, let's call it declaratively, what's going on in the system. So they either can make an assertion about how things will behave in a certain condition, and then when they don't see that condition actually occur, then they know, okay, we're violating some assertion, some part of that assertion. So that's what they go and start analyzing associated with it. So that's what I've seen in most situations, is that a lot of places we want to be able to say, okay, go launch this system rather than okay, I need to follow the next 20 steps to launch the system, and that's what we're definitely seeing in automation and capabilities.
Yeah, and indeed, the automation is critical. And I was wondering if you could describe how that's playing out and what DevOps teams should be looking for and looking out for and possibly implementing, and how that would play out.
Yeah, my general sense is it's playing out, I'll say slowly, though you could argue that it's a pretty accelerated pace. The big challenge, I think, in most of these situations is risk tolerance. Basically, people want to move very quickly, but at the same time, they want to know that they're not going to have regressions or problems that basically get introduced by moving too fast. So it's generally, what I've seen is over a period of, say, a couple of years, an organization will go from, okay, we want to release, rather than releasing yearly, we're going to release monthly, to releasing weekly, to releasing daily. And it really comes down to leadership understanding kind of the risks and tolerances associated with it, and then also building up the confidence associated with it. Somebody once quoted that if you want to have 5 nines of reliability, you have to go a minimum of, 2 years, I think it is, before you can really definitively say that you're at that level of reliability. It's kind of similar. We're seeing kind of a similar phenomenon, in my opinion, in the experience.
Yeah, I'd agree with that. And we haven't really talked that much about chaos engineering and things like that. But if you really want to get to that 5 nines place, I think that's a great point, Christopher, about waiting 2 years to feel like you've really achieved it. Like, I can be 5 nines for the next 60 seconds. I guarantee it, like, no problem. I can be infinite nines for the next 60 seconds, but you have to wait until you've survived a couple of natural disasters where an entire Amazon region goes out or something like that before you can actually say that you've gotten there. And the only way to guarantee resiliency in the face of those sorts of things is to simulate them fairly continuously, actually, and to validate that your system does the right thing when assumptions that have been implicit for years are being violated. So there's, to get to that level of reliability, I think requires more than just CI/CD. I think it requires injected faults and simulated disasters and things like that. But that can also increase confidence a great deal. I think to know that a system is resilient to those sorts of things and to actually know it and have data to support that hypothesis will increase the confidence in getting down to really bite-sized daily or multi-daily releases for individual pieces of the system. And certainly if you can get to that point and feel confident about it, the risk of a big change landing is so much lower, and those are the ones that are high risk. So oddly, I think there is a lot of evidence, of course, supporting that frequent releases can actually create more stable systems. But I would say frequent releases plus failure testing in advance, plus some way to understand issues after the fact and not just roll forward, roll back, roll forward, roll back. That's the anti-pattern that observability can solve. I think that combination can create like a genuine 5-9 system, even if you have to wait 2 years to validate it.
So going to the automation and the tools we've started to discuss, I was wondering if you could, Ben, if you could discuss or detail how the telemetry and tracing improvements and applying them to your organization has worked out, which you were then able to implement or offer to your customers. I guess I'm looking at, if you could provide a case study of your organization and what you learned, and then some of the key lessons that you were able to offer with your platform.
Vendors that provide observability and monitoring, I think, often run a pretty tight ship in terms of their own instrumentation within their walls, and Lightstep is no exception. But in some ways, I think I would actually I'd rather talk about customers that we work with or something like that than talk about our own organization, because the reality is that most developers don't really want to spend much time doing instrumentation. I don't blame them. It feels like it's off the critical path. of building new functionality, and it can be difficult to motivate. One of the things that I'm excited about that Lightstep has had some role in, I think, is the creation of initially open tracing and now open telemetry as open source projects that have really changed the way that this works. I think developers have long been reluctant to proactively spend a lot of time instrumenting things, and I think that's somewhat innate and is a tough thing to fight. Historically, what vendors did is they would provide an agent that did the instrumentation for you. It was sort of magical, although often a little bit of a black box that could introduce performance issues and so on and so forth. And what I'm excited about with open telemetry is that we've created a project where you get many of the benefits of an agent, in that open telemetry includes automatic instrumentation in languages where that's feasible. It includes broad support across the stack. It's, I think, the second most active project in CNCF behind only Kubernetes, and it's has a huge amount of traction from vendors and from various open source projects that are trying to get it everywhere. So you get this kind of automatic instrumentation and wide coverage, but you're not locked into anything, and it's a completely open project with a completely open governance model and a completely open set of standards at multiple levels of the telemetry stack, which allows developers to get decent coverage of their applications without really making code changes at all. So in my mind, open telemetry offers us the best of the agent world and the best of the open source world all in one. And my reflection on building observability at Google, we were able to take advantage of Google's monorepo to do a very isolated set of instrumentation to get huge coverage. That hasn't been as easy in the enterprise world because it's such a hodgepodge, and the creation of the Open Telemetry project does give both customers and observability providers a common a kind of a marketplace, if you will, to both create and consume telemetry. So I think that's by far the most important lever to getting high quality telemetry quickly that exists in the market today.
Christopher, is that overlapping a bit with some of your projects at GitLab?
We do have a little bit of overlap in our monitoring projects associated with that. I think Ben is spot on. What we've actually seen, particularly with our customers, is a high adoption rate where customers are starting to treat their developer experience as essentially what we call tier one or business critical. So if you think about it, one of the aspects that historically has not been the case is that developers were developing outside of that space, and whether the systems to actually build and deploy software was, second or even sometimes in a lot of cases tier three type considered service. And what we've seen is really to effectively manage the environment, both from an operations perspective as well as a microservices perspective. You really have to have that end-to-end application experience. So that's why we've particularly focused on single application experience, where we've definitely gotten feedback from customers say, hey, your product needs to be up 24/7. It needs to be highly reliable, and it needs to also scale in times of crisis, because there are definitely instances we've seen where the number of users can be quite voluminous in a given moment.
And we touched upon this a bit already, but GitLab has moved way beyond the days when it was, quote, just a repository code. And I was just wondering if you could describe where we're going and what developers and DevOps teams can expect, and maybe some of the key exciting things that are happening right now that haven't been discussed as much.
Yeah. Probably hasn't been discussed as much. Is a little bit hard because we're a very public company, and you can look at all our roadmaps and plans for our product line. The way I'd probably put it is that what we've spent a lot of time recently on is both expanding our base, particularly around the Git repository system, as well as CI/CD aspects, and then focused a lot more on security. But we've kind of gone breadth over depth. So we've really tried to spread across much of the DevOps, I should say DevSecOps experience. To think of it in terms of what are the additional things you need from a security perspective. So both scanners, static analysis scanning, as well as dynamic analysis scanning capabilities, thinking in terms of how do you deal with incident management, both from a security perspective as well as from a normal incident perspective, and really trying to get all those things incorporated into one set of tooling so that you have an integrated experience for that.
Exciting times. And how would you characterize, or what should happen with the evolution of UX experience specifically?
So I think what's going to happen with UX is very similar to what you're seeing us talk about in the concept of scaling. So what you're going to see a lot more of is capabilities around how do I deal with how do I deal with a specific problem? How do I get to that specific problem so that I understand where the problem actually is and solve it in a given situation? But then also, how do I represent the information to basically show how the service is running, or the organization is actually running in some cases? And I think that's what you'll see more of is we'll continue to focus on that, plus making the developer experience much easier in regards to what's holding them back from getting something done, and basically providing that information capabilities.
So Ben, did you want to add something before I go into the next question?
No, I think that I agree with everything that Christopher said, and I actually think what GitLab has done is pretty remarkable from a product standpoint. The breadth versus depth thing is a nice, simple way of putting it, but I think understates the importance of having like a single home for a really expansive set of tasks that developers need to handle, and I think it's borne out by how well adopted it is as an overall ecosystem of technology.
I mean, how far are we away from where we're going to merge, and ideally a single interface of putting everything in a single framework for security, observability, telemetry, tracing, and logging, for example? How far are we away from that day, and where are we now?
So this will probably be an interesting one, because I don't know if we'll ever get to a unified theory on this. My personal opinion is we're still pretty we're a long way away, and the reason why I say that is because in large companies that are invested in this, say in the tech business, I think they're going to converge on it much more quickly. Particularly other companies that are at large scale. You've seen the companies basically get to that point. But for a lot of enterprise companies, they have policies and procedures in place and tools that they've used for a very long time, and they're probably not going to replace those tools in any shorter, let's say 5 to 10 years maybe, but not certainly in the next 2 to 3 years. And because of that, that's what I see is adoption over a much longer period of time. The other thing is Ben mentioned earlier about chaos engineering. While that's been published for a very long time now. Reality is its adoption rate is still fairly low. So I think there's definitely new areas of operations experience that we still haven't yet to flesh out and really get industry-wide adoption on.
Yeah, and I would agree that we're a long way off from. In some ways, I wouldn't even frame it in terms of the telemetry, but in terms of a well-defined, commodified user experience where everyone knows exactly what they should expect from observability. I think the fact that we're still talking about the telemetry as if that's the point of observability is reflective of how early we are in this process. But in my mind, the goal is pretty simple. Developers should be able to create the changes that they want and mitigate the changes that they didn't want. Both those things should require almost no manual effort and should be mostly automated. Observability is the second one of those, obviously. And I don't even see most observability tools. That's literally the point in my mind. And they don't represent those changes well in their own products. So for me, that's good news. I think there's a huge opportunity, but we are still in the early days, and it's still mostly parametric search, as I said, which I personally find to be necessary, but way, way, way far from sufficient.
At the same time, as you said, this creates a lot of opportunities for development, and it'll be exciting for those of us who love technology and for the developers as well to see what happens, I think. Christopher Lefelhocz, Vice President of Development for GitLab, Ben Sigelman, CEO, Lightstep, and founder. Thank you very much for joining us. It's B. Cameron Gain, correspondent for the New Stack.
Thanks for your time.
Thank you.
Listen to more episodes of the New Stack Makers at thenewstack.io/podcasts. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.
GitLab is a single application for the entire software development lifecycle. From project planning and source code management to CI/CD, monitoring, and security, GitLab helps enterprises deliver software to market at new speeds.